All right, this next video for this section is going to cover what is called a factorial. I'm not sure that you guys have seen factorials before in any of your math classes. You might have. I think actually if you've taken AP Stat, you've probably seen factorials before. You deal with them a lot when it comes to probability. And then also in Calc BC, you're gonna see them a little bit as well. So just a quick review, if you don't know what a factorial is, it's this little exclamation point that you see in math. And all that it means, if I told you to figure out what 5 factorial is, all I want you to do is multiply every single number down. So 5 times 4 times 3 times 2 times 1, and you stop there. Because if you were to go to 0, our answer would end up being 0. So you stop when you get to 1. And then you multiply that all out. So 5 times 4 is going to give me 20. And I can do this in groups if I want. Oops. 3 times 2 is going to give me 6. 20 times 6 is going to be 120. Okay? And then times 1 is just going to be 1. So 5 factorial is going to be 120. You can do that on your calculator, but remember, you guys probably know from pre-calc, you can't use your calculators a lot when it comes to this stuff. You have to show that you know how to reason through it without your calculator. Okay? So the next one, we have 3 factorial over 5 factorial. So I'm going to write this out first. So 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1. Now, this part of it right here is technically 3 factorial, right? If I would have gone from here, that would have been 4 factorial, and so on. Oops, what's going on? So just know that like you can rewrite it in several different ways. So what we see here now is that this 3 factorial right here is going to cancel out with our 3 factorial on the top. And we're left with just 5 times 4. So 5 times 4 is going to give us 20, but it's down in the denominator, so I got to put a 1 up at the top just to placehold. Okay? Now, this is where it's going to get a little bit tricky. I have a variable now, n plus 2 factorial. So I don't know what the number is, but I know that if I decrease it by 1, so if I went from 5 to 4 to 3 to 2 to 1, I don't know how big this is, so I don't know how many terms I'm going to have, but I know that if I have n plus 2 as my first term, what's 1 less than n plus 2? It's got to be n plus 1. Right? And then what's less than n plus 1? It's got to be n. And now we stopped at 1, but I don't know what n is here. N could be 20. So if n was 20, then I'd have to do 19 next, which would be 1 less. And so on. Now this is technically never going to end, so I'm going to put 3 dots there. Okay, it's going to keep going. Now, if I wanted to, right here, if I started at n plus 1 and kept going down, that's technically n plus 1 factorial. So I'm just showing you a variety of different ways to write n plus 2 factorial. There's really no right answer to number 3. I'm just using it as kind of a piece to show you how to simplify for examples 4 and 5. If I started with n and went all the way down, n all the way down would be n factorial. If I started with the n minus 1 and went all the way down, I would get n minus 1 factorial, and so on. So wherever you kind of start is what the factorial is going to be. So let's try to simplify. I have 2 that are a little bit tricky here for you to simplify, but this is where the factorials and the idea of them is really going to come into play when you're simplifying, okay? So I have n plus 2 on the top, and I have n factorial on the bottom, which if you look up here in red, right here, I broke down n plus 2 so that it had an n factorial in there. And since I have an n factorial down here, I need to try and get something to cancel out here. So I'm going to rewrite n plus 2 as n plus 2 times n plus 1. And then this whole chunk right here, instead of writing out the rest of the factorial, I'm just going to write it as n factorial because it's going to keep going on and on and on and on and on. Over, now I have n factorial in the bottom, which I'm not even going to write that out because I can already see that I have something that's going to cancel here. Numerator, denominator, all I'm left with now is n plus 2 times n plus 1. And that's your final answer there. We don't know what n is, so I can't really solve it to get an actual numeric answer here, but we're just simplifying the expression that has a factorial in it, okay? All right, last example, we're throwing a couple of coefficients in there. Okay, so I have a 3 and a 2. Now the 3 and the 2 don't really apply to the factorial. They're kind of just coefficients that are out in the front. So I'm gonna leave the 3 and the 2 out there. Now I'm gonna look for what's bigger here. So the n plus 1 factorial and n plus 2 factorial. Since this one has a plus 2 in it, this one's actually bigger than my top one. So I'm gonna leave the top one there. And I'm gonna try to rewrite n plus 2 factorial so that it has n plus 1 in there as well. So up here you'll see in number 3 in the orange, the first thing I did, which I'm gonna write over it in blue. N plus 2, and then this whole rest of it, I rewrote as n plus 1 factorial. So this and this is still equivalent to what I began with. Okay, so I'm gonna rewrite n plus 2 factorial as n plus 2 and then just n plus 1 factorial. Instead of going all the way down, I'm just gonna stop there. And the reason why I stopped there is because now I can see those are gonna cancel and I'm gonna be left with 3 over 2 times n plus 2. So we got rid of our factorial, makes our expression a little bit simpler. Okay, there's a question that's in the practice that jumps right to these harder ones. So if you need to watch the video over again, if you have any questions on this, because I know it's a new concept for you guys, please let me know and I can help you guys think about how to simplify it. Okay?